So let's discuss a little bit of the process that gives rise to mathematics. You may begin by perceiving the real world. Take, for instance, you see a moving car, you hear the sound, you smell the exhaust, you feel the vibration. So you are perceiving a moving vehicle. In your mind, you will think qualitatively by looking at the colors, red, white, green. It's looking aesthetic beauty and so forth. However, simultaneously, there will be quantitative thoughts, quantitative mental thoughts using words. Because when we think, we use the words that we naturally speak, our native language. Here, English words, I saw a car moved a distance of 200 meters in 10 seconds from left to right. So you are not only thinking qualitatively, but you are also thinking quantitatively. The distance moved in time, all right? Therefore, the velocity, a concept that you abstract, the velocity of the car must be 200 meters in 10 seconds in the positive direction. So from the real to words, and from words now to facilitate the documentation and the communication of the idea that's in your mind, your mental thoughts, quantitative written reasoning using graphs and symbols, is developed. Here's the graph to depict that activity. Your vertical axis, which is distance in meters, your y-axis, distance in meters, your x-axis, your horizontal axis, time in seconds. And these two variables are depicted in this graph. Bear in mind the line that you see will indicate how the distance is varying. So the x-axis always increases from left to right. The values on the x-axis increases from left to right, but the y values will be depicted by the line on the graph. So this line is telling you that the y values are increasing from 0 to 50, 50 to 100, 150 to 200 meters in 10 seconds. So D for distance. So here you can see words turn into symbols. 200, here's the symbol for 200. Here's the word for 200, here's the symbol. Time, here's the symbol for time, is equal to, here's the symbol for is equal to. 10, TEN 10, here's the symbol for 10. So words turn into symbols. V for velocity is equal to 200 plus 200 divided by 10 to give you plus 200 meters per second. The plus is from a direction from left to right. So you can see the transition from symbol to words, from the real perception to words to symbols. And this words does not look like math, but you can actually see when you familiarize yourself with these symbols and say, well, this looks like math, but that's where it came from. And it is conveying the same information that these words are conveying, which is what is being perceived. So communication using words, communication using language, translation from words to language, mathematics can be considered a language. Okay? So that's why mathematics brings to the table, you can consider mathematics bringing to the table this process of perceiving reality, seeing, hearing, smelling, tasting, feeling, intuiting, and you have words in the mind, depending on the native language that you speak, qualitatively and quantitatively simultaneously. Qualitatively, colors, texture, and aesthetics. Quantitatively, height, weight, how many, the cost, the temperature, both happening simultaneously. If you need to communicate, because socializing means communicating what you perceive using words or written language, Qualitative reasoning is writing using words. Quantitative reasoning translates words to mathematical symbols. So you can say this about mathematics. It first starts when we objectively perceive the real world with the five senses, or the sixth sense also. Then in order to communicate the subjective abstraction of the mental image that was formed in the visual cortex and the other areas of the brain, we design diagrams and graphs. We also convert words to symbols. In that way, we facilitate the documentation, just written communication of ideas involving numerical analysis. Okay, so therefore now you can actually see the transition from the real to words, all right, to symbols, from the real to words to symbols, and this gives rise to the definition, one of the definitions of mathematics. Okay, then you have the plus sign, very famous sign in mathematics. The origin of the plus sign can be credited to the 14th century French mathematician named Nicolas de Orasem. When he was writing his math book, he found himself having to write the word et over and over. For example, in Latin, you can see tria et quatre égale 107. In French, trois et quatre égale 7. In English, 3 and 4 is equal to 7. So in Latin and French, the word for and is et, et. So he therefore then replaced the word et with the letter t. Instead of writing et every time, et. And with time now, the t now evolved to the plus sign, the horizontal line go down a little bit, right in the middle. You know, languages evolve in time. So the words et to translate to symbols, the plus sign. So here we can see the translation from words to symbol. Words is language, symbols is the same language. Mathematics can be considered a language. And also take note, in arithmetic, the word and is plus. If you say and, you want to translate to mathematics, you can use a plus to replace the word and. For example, you may think, well, 5.5, that's a mixed number. And when you see this mixed number, you say 5.5. Agreed? When you read this, that's what you've got to say in English, 5.5. 5.5, which is the same as 5 plus a half. 5.5 is the same as 5 plus a half, you know. For example, you have 5.5 plus 4 is equal to 5 plus a half plus 4, that's 9.5. 5.5 plus 4 is 9.5. Okay, you have 5.5 and you add 4, you have 9.5. Okay, so always remember, and is the same as plus in arithmetic. Okay, then you have the equal sign. The origin of the equal sign is credited to the 16th century mathematician named Robert Record. When he was writing his math book, he found himself having to write the words is equal to over and over. Again, 3 et 4 égale 107. 3 et 4 égale 7. 3 and 4 is equal to 7. Is equal to, égalant, égale 100. So therefore now, instead of writing all of these, what he did now, he replaced the words égale 100 or is equal to with two horizontal parallel lines of equal length. Words, égale 100. All these words to two equal parallel horizontal lines. And we call it the equal sign. Okay, words to symbols. If you look it up, 3 and 4 is equal to 7. 3 et 4 égale 7. Okay. 3 and 4 is equal to 7. 3 et 4 égale 107. Okay. Words to symbols. Always remember that in mathematics. Again, the origin of the numerals is credited to the Indian mathematicians, the symbols that we use for numbers. the Hindu Arabic numeral set of 10 symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When we see that, that's what we have to see. That represent numbers in the decimal number system. They originated in India in the 6th or 7th century and were introduced to Europe through the writings of the Middle Eastern mathematician, especially Al-Khwarizmi and Al-Kindi, about the 12th century. Now, these symbols were designed via the rule of counting the number of accurate, right, and also obtuse angles. So all the angles, all right? And that's how these symbols were created, by counting angles. The whole idea of perceiving reality and want to quantify by counting, okay? When you look at your environment, you will see colors, you will see texture, but at the same time, you automatically counting, and you want to communicate this quantification that you are doing mentally. Symbols has to be created. So instead of writing vertical strokes like the Romans 1, 2, 3, and then a V for 5 and X for 10 and so forth, because they say, well, probably the X because this in 10, the X, there's an X in, and so forth. You never know. But this was a little bit cumbersome. So the Indians invented one symbol for 0, because a 0 does not have any angle. 1, there's an acute angle there. That's a symbol for 1. The 2, because there are 2 acute angles. It looks like a Z, but because there are 2 angles, and that's how you see how it evolved to the curly 2. Languages evolve, symbols evolve. The 3, 1, 2, 3 angles, and that's how it evolved to the curly 3, but that's where it originated. 4, 1, 2, 3, 4, and that's where it evolved. It did not really change much. The 5 became curly in the lower half, but the upper half remained, square. 1, 2, 3, 4, 5 angles. 6, 1, 2, 3, 4, 5, 6. That's where the 6. That's where the 6 originated from. The 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, and you can see the similarities, but they become a little wrongly. The 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 angles, and here's our 9. So therefore, words to symbols. Here's the symbol now, and we call it mathematics. Okay. 3 plus 4 equal 7, and we call it mathematics. But that's what we say. If you speak in Latin, you will say 3 et 4 égalant 107. If you speak in French, you say 3 et 4 égalant 7. If you speak in Spanish, you might say 3 más 4 es igual a 7. All right? That's what you will say, but the symbol remains universal. So that's why sometimes they say mathematics is a universal language. All right, so here you can actually make the correlation from words. 3 and 4 is equal to 7, to symbols. 3 plus 4 is equal to 7. And in arithmetic, is always plus. So always bear that in mind. Mathematics can be considered a language, the translation from your native language to symbols. The whole idea is to communicate quantitatively in a written form.